enabler. But now it's time to change the phrase. Now it's not business enabler only. Now it is going to be humanity enabler. And why I'm saying that? I have strong reason behind that. So there are so many things which is happening in the technology area, in cloud area. So we all know 5G is also on the plate. So cloud with 5G, there are in the collaboration, it is creating a strong platform which is going to be helpful. What we had seen past 2 years due to Corona. So in the healthcare sector, imagine we used to see the telephone booth sometime back at the corner of the street, right? Likewise, in the same manner, there will be medical booth, let's say, okay? If anyone is feeling any problem, medical condition or something, they just go over there, they just plug in their hand or whatever procedure is there. And then based on the analysis, the respective shot, respective drugs will be injected immediately without doctor, with perfect manner. Imagine that kind of thing. Obviously, that kind of things are coming, right? So that's where the cloud is doing a strong collaboration with the 5G. Yeah, we cannot forget the cybersecurity area. The more we are exposed to internet, the more we are exposed to the world. There are so many threats, known and unknown. Every day those will be increased. So of course, in the 2023, the major focus area is going to be on the cybersecurity as well. And integration, right? Integration is another aspect which need to be covered. So we know, and we used to call that legacy system, right? I think legacy system integration is not going to be more challenging, because the integration layer, integration services, integration platform coming into the picture, like Kafka, Azure service, okay, we have Rubik and other services. Those are going to change all the integration challenges paradigm, and those are going to be plug and play kind of thing. So we can say legacy will now more challenge for anyone and everyone. And Kubernetes, the use cases for Kubernetes is going to be increased. Of course, a skilled definition, a skilled person, a skilled team is needed to be part of a successful Kubernetes to actually leveraging the full capability of the Kubernetes. So in our organization, the existing team, skill, resource capabilities are going to be changed. And we cannot forget DevOps. DevOps is the parallel stream, and in DevOps, so far we just use CI/CD, just continuous integration, continuous deployment, but we haven't thought the capability to extend it further. So imagine going forward, what could be the possible use case for the DevOps? So in the DevOps, basically CI/CD, automation, complete automation when I'm saying, so like human, they validate the test cases for business critical services. Still we think we cannot rely on DevOps, we cannot rely on complete automation. We cannot rely on complete automation. Considering that situation, the automation will be integrated with the AI, right? AI, the actual case of AI. So far, we know there are very limited use case of AI, because there is a fear factor also which is involved. We cannot trust AI 100%, right? But going forward, the AI models are going to be mature, and that few of the use case will get implemented in 2023 itself. That we will see. We will adopt them very easily. That will become part of our day-to-day life. We had seen IoT, we had seen so many things coming into the picture in our day-to-day life as well. Even some of the use cases we don't even know we are already using. So this is how the technology is getting improved. This is how the technology is becoming part of our day-to-day life, right? So there are so many more, and that's why now we don't talk about the 5-year plan. We used to do that. I do remember in my organization also, and some time back, when we talk about the long-term plan, we used to say, okay, let's plan for 5 years. Now there's no 5-year plan. Let's talk about now. Let's talk about this year only. Yeah, because for sure, whatever plan you are going to do for 5 years, that is not be relevant, even your second year or third year itself. So there are so many things which is going to change our life. So with that lighter note, so enjoy our learning today. With that, I invite Mr. Ahmed Safnaj for CI/CD. Just give a big applause of a hand. Okay, just welcome.
Morning, Singapore. Good morning. Nice. So I'm going to talk about how you can level up your CI/CD workflows using GitHub Actions. So I prepared these sessions for beginner friendly. I don't know how many of you are students. So can you raise your hands if you are a student? Okay, we have a couple of students, right? Fine. So let me start the session. Okay, before that, let me do a self-introduction. So my name is Safnaj. I am coming all the way from Sri Lanka, and currently I'm working as a software engineer at Cisco Labs, a small advertisement here. And these are some other communities that I'm being a part of. So if you want to get connected with me, or if you have any queries, you can reach out to any of my social handles. So yeah, that's all about me. And yeah, the agenda is simple. We're going to talk about what is CID, since this is going to be a beginner friendly, and why we need to use CI/CDs, and what is actually GitHub Actions and what are the benefits of using GitHub Actions, and finally we can have a demo if the time allows. Okay, let me remind you the hashtags for today's event. So if you are posting something on social media or if you are sharing your feedbacks about my talk, make sure to follow these hashtags and my handles. Okay, let me tell you a story of a typical developer. So as a typical developers, we used to develop applications and then we do some manual testing locally in our PCs and then we deploy, right? Then we used to pray to make the deployment successful, and we will be again do some testing on deployed environment, and if it didn't work, we had to go back to the develop stage. If it is work, we have to pray more to keep the application successfully. So this is the saddest life cycle of a typical developer, where CI/CD was never exist. And that's where DevOps came into picture. And back in 2000s, like departments like developers and QEs, IT team, and security, they work individually to achieve something like much needed in the IT industry, right? So basically, developers used to code, and QEs will be testing. You guys know the stuff, right? So CI/CD, can someone tell what is stand for CI/CD? This can more into specific into students. Yeah, it should be continuous deployment or continuous delivery. Yeah, it's correct. Okay, I will give some GitHub figures. Make sure to ping me. Okay, so CI/CD stand for continuous integration and continuous delivery or deployments. So let me start with what is continuous integration. So it is actually a phase and a practice in software development cycle. So where developers work together in a single project and regularly do merging codes. So this is basically we will be carrying out some basics such as unit test and integration test. Maybe you can have some code quality checks. So within a short-lived environment. So what does it mean by short-lived environments in the sense? So you just need to spin up an instance for a simple need, right? So you don't need to run all the time. And you can set up your repository where someone, every time they push the code, the CI can trigger and it will be running. So if there are any build or fails, it will notify the relevant team. So you can have a look at what happened on CI pipelines. So typically the CI pipeline involves the following task. So it is used to detect changes in your source code, and we can build and generate the artifacts that we need to deploy, and also we can perform basic tests such as unit test and integration test, and you can have a status of report. So if you are having a code checker, so there will be a status of report of what is the percentage of your coverage. And if the above steps fail, as I said earlier, this will notify the relevant team, so you can have a look and fix the stuff. So there are some benefits of using CI. So first one is to developer productivity. So you don't need to build your applications manually, where it's time consuming actually, and so there you can save some time, and you can find the bugs and address it earlier before it's reached to production and grow big problems later. And you can deliver update faster, right? So you just push the code, so the CI will be running, so you don't need to spend some time on your manual works. And let's talk about what is CD. So CD is a software engineering approach. So code changes can automatically deploy into a configurable environment. So it could be a testing or production environment. So in practice, in simple term, developers' code changes can go into live within a minute after writing it. And if we can discuss about the benefits of using continuous delivery, it's automate the process of software releasing. So you don't need to build the stuffs and take into your server or whatever the platform that you prefer. And again, the developer productivity is high, and you can find and address the bugs earlier, and you can deliver the update fast. So typically, CI/CD pipe can contain cases. One is where you can build and test and generate some artifacts for your pipeline, and the second phase is CD. So where you grab the artifacts and deploy into a server or something. So let's talk about GitHub Actions. So automate your workflow from idea to production. So we have seen such as some 8 phases in DevOps cycle, right? So you can automate all those 8 phases using GitHub Actions. So you don't need to spend some time on your manual works in any phase. So when it comes to achieving DevOps culture in your company or your personal projects, so automation is a crucial component, right? So GitHub Actions allow you to automate, customize, and execute your software development workflows right from your repository. And yeah, you can build, test, and deploy code from your repository. So you don't need to spin up some server. You don't need to connect your repository with some webhooks. So you just have the configuration. That means the workflow file in your repository. It's simple as that. It will work. So why we need to use GitHub Actions? So the first point is it supports multi-operating system, starting with Linux, Windows, and Mac and containers. So container is something we need to highlight here. So if you are coming from a Docker background, so you don't need to go with VM. So you can simply run your CI/CD stuff containers. And metrics builds, if you want to test your application in multiple operating systems, such as Linux and Windows parallelly, GitHub Actions allows you to do that. So you can save more time on that. And any language, so far it supports most of the programming languages such as Java, JavaScript, and you can see in the slide, Go, Ruby, and stuff. And live logs. So right after your workflow triggers, you can see the logs, what's happening in your CI/CD pipeline. So if something goes wrong, you can have a look at your logs and you can fix it earlier. And the next point is built-in secret store. As a good developer, it is a best practice not to hard code the secrets and the token stuff in your source code or pipeline. So GitHub has its own secret store where you can have organization level secrets or repository level secrets. So it can be, you don't need to hard code the stuff. And multi-container testing, again, it's similar to DevOps stuff. If you want to run the CI/CD against your containers, so you can have a multi-containers and make it easier. And again, it's simple, right? So you don't need to be a super duper expert on DevOps. So if you are a developer who knows some basic stuff on how to run a CI and how to generate the artifacts, it's simple. That's it. You don't need to have a wider DevOps knowledge to do to work with GitHub Actions. And there are like 5 components in GitHub Actions: events, steps, jobs, actions, and runners. Let's discuss one by one. We call it as a workflow file, which need to be written in YAML. So a workflow is simple. It's a configurable automated process that will run one or more jobs in your repository. So it's need to be defined in YAML, yet another markup language. So a single repository can have multiple workflows. So you can have a workflow to run a CI. You can have another workflow to do some lint testing. You can have one more workflow, any number of workflows in your repository to perform some different tasks. And it's need to be defined in the directory called .github/workflows. Otherwise, it won't work. And again, there are some rules for that. And a workflow should contain one or more events that can trigger the workflow. It's need to be triggered, right? It can have one or more jobs to execute the workflow in your animations. And either you can have a script or you can use actions templates. So typically, this is how workflow 5 will look. So this is a simple node CI pipeline. So here you can see the event will be listening to on push event on master branch and the pull request for the same master branch. So when someone made a someone actually directly pushed to the master or someone made a PR to master, the workflow will start. And here you can see we can have a variables defined there, so you can reuse it later. And you don't need to always run your own actions using shell script or something. So you can use templates. So this is the checkout template. That's mean you once you run your CI/CD in a Ubuntu server, you need to have the source code in a VM, right? So you just use the checkout action from action repository. So where we define the Node.js version and stuff. And the next one is shell script. So if it is a Ubuntu machine, you can, once you install the Node.js and stuff, you can perform these commands, right? So that is it. And this is a simple CI workflow will look like. Yeah, additionally, we have one more step where we upload the generated artifacts into these particular locations. So this is a typical CD workflow. So what we do is the above step is to build the artifacts, and the deploy steps are defined to download the artifacts from the directory that upload, and we are deploying to AWS. Here we have the secrets and stuff. So this is not hard coded. This is coming from the GitHub Actions built-in secret store. So events, we have like hundreds of events that can occur in a repository. So these are some events that can occur. So here you have a link where you can see more about what are the events that gonna trigger in a GitHub repository. So you can have a workflow which can trigger based on someone pushed or someone made a fork, or you can even run cron jobs. And there are like two types of GitHub events. So one is single event. So basically this event is going to be triggered when someone open an issue in the repository, otherwise it won't. And you can have a multi-events workflow. So basically this particular actions will be running when someone push or when someone fork in the repository. So jobs is basically it's a combination of shell script where you can reuse it later, so you don't need to always write the shell script for all you need. So it's simple as reusing the piece of code. And actions. So as I said, you can use actions from different vendors in marketplace. So you can I will show you how it will look like in marketplace. And it's simple as event that triggers workflows, it's going to run some actions. So you can automate your workflows. Here you can see some very famous templates such as deploy Node.js to Azure web app and publish Docker containers. So you don't need to write everything from the scratch. So if you want to publish a Docker container right after you merge a pull request, so you can configure this template which is available in GitHub Marketplace. That's it. So we have more than 11,000 GitHub Actions template available in GitHub Marketplace. So you can have a look. And how you can use GitHub Actions. Here I will tell you some like interesting stuff. So first thing we discussed about we can create the CI/CD pipelines using GitHub Actions. Second one, you can auto label your pull request. You can have some configurations of what label need to be added if the PR contains these keywords. So you can do that as well, and you can generate Lighthouse report. How many of you are front-end developers? One, only one. Okay, sad. Okay, so if you're coming from a front-end development background, so you have to check your site scores using Lighthouse, which is available in Chrome. So every time what we do is we used to test the report manually, so it will take a lot of time. At least 5 to 7 minutes will be there. So you can configure that stuff in GitHub Actions. So right after you push the code, Lighthouse report will generate to you, so you can check the score there. And you can have a code quality checker. So if you are working in a strict company like me, there will be a code quality checker. So you can have a SonarQube configured over there. So if your unit test and the code quality stuff is above the threshold, your PR will be passed. Otherwise, it will be failed. And as we saw, you can build containers and publish Docker images. So you don't need to remind the difficult Docker commands, and you don't need to do it manually. So you just push the code, Docker image will be published in your configured environment. And security analysis, that's an inbuilt feature in GitHub. If you are like hard-coded any secrets, or if you have any vulnerabilities in your source code, you can even have an action for that. And automated infrastructure creation. So this is something hottest today, and Terraform, you can create your infrastructure using GitHub Actions, and unit testing, linting. If you are coming from a JavaScript background, you know about linting, right? So you can lint your code automatically, and you can deploy your application to any cloud platform, or we have like more than 11,000 of GitHub Actions for all the cloud vendors. So you don't need to write everything. So you just use the template and go. And send messages to or notification to people. So you can configure templates. If the CI got passed, notify these people, and if the CI is failed, notify this set of people. So you can configure those stuff as well. And finally, you can even order pizzas using GitHub Actions. So I have seen a company every sprint, if the release is successful, the GitHub Actions will automatically order number of pizzas for the team. So that's the condition they configure. So let's discuss about the pricing. So we have some blah blah pricing based on the OS and the number of minutes that you're going to run. So at GitHub, they love open source, right? A lot. So if your project is a public one, GitHub Action is free for you. You can use any number of minutes for free. So I have a demo. I think I am running out of time. So let me show you the repo where you can see the workflow. So this is the demo I had. This is a simple React application. So I need to deploy this React application to Firebase. So if when someone's merged the code, it needs to be deployed into live environment. Here you can have a look once you want to do the same. And this is the live channel workflow, and the second one is non-live. That means like this, I have configured this workflow. If someone made a pull request to master branch, so as a front-end developer, I don't need to clone that particular branch and check the changes. So this will deploy to preview channel in Firebase hosting. So when someone made a pull request to master branch, so there will be a channel generated for that. So I can have a look at, once I deploy, there will be URL generated in the PR description. So I can have a look at the UI changes there. So that's the demo. Sorry for not starting the demo from the scratch. So I'm running out of time. And a little bit where to go from here. If you are a student, please go for GSOC and create your own GitHub Actions. If you are a Linux background person, you can create your own GitHub Actions and publish on GitHub Marketplace, so someone can make use of it. And open source and keep contributing to community. If you have any questions, it's the time.
Please hang on. Yeah, well, we have time for a couple questions, if anybody has some. Thank you very much, Ahmed, for your talk. Yes, please go ahead.
Yeah, so how does the GitHub Actions to test on a wide
It's depend on the OS and the size of applications. So if you are going with the free plan, there's a limit for the CPU power, right? So based on that free plan, on your size of applications, it will take some time.
So for a small Discord bot and you want to implement, GitHub Actions, how long would that take?
What language? Python or something?
Python, yes.
Yeah, Python. It will take probably with the free plan within 4 minutes you can get it done.
Okay, thank you.
All right. Any questions? Yes. That's sort of a topic. I skipped those slides. So because if you have your own VM running on AWS or Azure, so you don't need to pay for GitHub. So you can configure the stuff to a VM. So the CI/CD pipeline will running on your machine, your own machine. Yes.
Does it always sacrifice time?
Sorry.
Time when you develop in local is faster because when you have npm install, you will not npm install in your local, right? But in CI you always
It's crashable. So
it's crashable by Slack, but it will still be install, right?
yeah, we need to install. So otherwise the code will break, right? If someone has a vulnerability dependencies, the CI will fail. So that's where we need to always do some npm install in the CI pipeline as well. Any more questions? Yeah, right? Okay.
All right, thanks a lot again, Ahmed.
No, I'm just going to. Oh, actually, that would work. Have you got a clicker thing? That's right. It's going to have to stand somewhere different, I think. Can I move it over? Yeah, sure. Will that work?
You want to actually put here, it's fine as well.
No, this should be fine.
Would it be good if you want to put here and maybe the cable is on?
Oh, yeah, it should be. If I can just sit here. Stand here. Is that? No, that's right. That'll work.
Yeah, that will work. We can move the camera, that's fine.
Cool. All right. We're off. All right. Thank you. I think these guys need the applause. I haven't done anything yet. All I've done is turn up. So great. Thanks very much. I'm Paul Bradner. I'm the open source technology evangelist. I work for Instacluster in Canberra. We've recently been acquired by NetApp by their cloud part, which is called Spot, which does stuff with Spot instances on cloud providers, so I believe. So the inspiration for this talk came from where I live, which is Canberra. It's called the bush capital in Australia. It's very unlike Singapore. It's very low density, and I live right next to the bush. And about a year and a half ago, one of Google's subsidiaries started doing some drone delivery trials over the top of our house, which I thought, well, initially I thought this is cool. We can get drone deliveries like our neighbors. We're getting, I don't know, donuts, coffee and stuff at all hours of the day and night with these drones buzzing over our property. So I downloaded their app, put in our address, and they said, no, you've got too many power lines and trees and things, which is really annoying. So we had to put up with the buzzing drones while our neighbors got the free, well, not free, but got the exciting drone deliveries. So at that point I thought, okay, I can come up with a more interesting story around drone deliveries for a demo application. So this is more or less, that's the origin of this story. I don't think it would work in Singapore. I think the density of living in Singapore might be a challenge for this. Instacluster provides a managed platform for big data open source technologies. We've got a whole bunch of technologies around storage, streaming, analysis, search. And the latest one that I'm talking about particularly today is orchestration. It's a workflow orchestration technology, Uber's open source Cadence. So it fits in really nicely with the previous talk around workflows as well. This is something that's focused a bit more at the enterprise level, high scalability workflows. So workflow orchestration is basically pretty simple. It's just about task ordering. You want to start something, you want to perform a task, you want to perform another task, and then you want to end. So it's relatively straightforward at that level anyway. So doing that with cadence, pedaling with high cadence in the bicycle world is called spinning. Mashing or grinding is slow and bad. So you want to spin your workflows basically at a high cadence. Cadence is fault tolerant, so workflows can and will fail, and at that point you want to be able to recover from them in a sensible way. Cadence is horizontally scalable. Essentially, the number of workflows that you can be running at the same time is unlimited. Cadence workflows are just code. So that's one of the nice things about Cadence. Here's an example of a couple of tasks being performed in sequence. This is a workflow implementation of 2 tasks executed sequentially. In terms of the architecture is a bit complicated, which is why we provide it as a managed service. At the back end, there's actually some databases. Cassandra is the one that we prefer. Postgres works as well. If you want to be able to do what they call enhanced visibility, so you can see what's going on, you also need a Kafka and OpenSearch, but they're optional, which I won't talk about in this talk as well. So Instacluster actually provides the managed cadence part of the system and the databases as well. You as a developer actually have to write the workflow code and run some workers as well, and that's run on the client side, so you need some EC2 instances running on Amazon or something to actually be able to get that to work as well, and that just connects via APIs to the managed cadence. So yeah, the workers run the actual workflow logic, and Java and Go clients are currently the 2 supported client types. So just looking under the hood a bit, how does Cadence fault tolerance work? Well, it's essentially using event sourcing, which is sort of it's been around for a while, but it's a continued hot topic. This basically means there's a history mechanism and replaying of the history. So essentially, as the workflow is executed, the history is written to the database, which is where the database side of the story comes in. That's the persistence mechanism. And then you get workflow state recovery by replaying the history. So if there's a failure at some point between task 1 and task 2 in this example, the failure actually causes the complete history to replay back again. And the replay basically recreates the workflow state and the restart point to continue the workflow from. So it all continues to work as if nothing bad has happened. Cadence activities. Cadence activities are quite central to Cadence activities, including things like cycling backwards can fail. Remote calls can fail. So one thing Cadence is used heavily for is calling external systems, and that call can fail. So what you do is you wrap them in activities. They can contain any arbitrary code you like, and activities are executed at most once and can be automatically retried on failure. There's a couple of restrictions around activities. Replaying must not produce new history events. Activities are executed at most once, and this ensures that once they succeed, then the result is basically fixed or immutable. The other restriction is around workflows, the actual sort of top level of the workflow itself. Replaying, again, as I said, must not produce new history events. So due to replaying, workflow code is executed multiple times, and that's by design, so it must be deterministic. So you actually have to use some special built-in methods for things like time, sleep, random number generation, anything that has side effects. Otherwise, something will blow up at that point. So this example here actually shows the use of the inbuilt time function. So what are some good use cases for Cadence? Well, essentially when you've got a very large number of running workflows, things that are long running processes with sleep and scheduling are also a good candidate for Cadence. Anything that requires any stable, fault-tolerant application execution. Complex workflows are a good example. Integration with unreliable external systems, integration with streaming and event-based systems, for example, Kafka. And the other constraint, I guess, is that really it works best for short workflows with hundreds of steps rather than with very long workflows with very large numbers of steps. This can have a side effect in that when the history is being replayed on failure, it can take a longer period of time. So that's perhaps the one case where you don't want to be using Cadence. So what are some good examples for finance, retail, and as I mentioned at the start, delivery? So hence spinning your drones. A drone delivery demo application is what I came up with. So drone delivery is sort of complicated. It's got a lot of steps in order to be able to have some drones starting at a base, ready to go. Then an order is put into the system by a customer. They want some donuts delivered or something. So the drone has to get that request. It has to go and actually physically pick up the order. It's got to then fly to the actual location where the delivery is to be made, deliver the order, and then fly back to base and get recharged and repeat and get ready for the next sequence of steps. So it's reasonably complicated. The actual flight for the drone is quite complicated. So here's an example of a drone delivery flight on imagined a desert island or something. Basically, there's a drone base. It's got to fly to the order location, fly to the delivery location, and then fly back to the base again. And that all requires fairly complex calculations. Remember, this is all simulated. I'm not actually flying drones, but I've done everything that would be required for a real drone flight, basically. So the drone flight path is computed inside an activity. That's where all the complex numerical calculation happens, because it can fail and you want to know where your drone is at all times. It uses location, distance, bearing speed, and remaining charge, and it does this every 10 seconds, so it knows more or less in real time what's going on. If one of the activities fails, the drone won't just suddenly crash and fall out of the sky. It'll continue flying from its last known location. So just having a bit more of a look at the overall system. I'm using some swim lane diagrams here to explain the different parts of the systems involved and the steps involved as well. So here's the first workflow. There's actually two cadence workflows. This is the first one, the actual drone workflow. And this basically does the stateful sequencing of the drone, starting, being ready, waiting for an order, doing all the movement activities, recharging, and repeating again. So that's relatively straightforward. But there's actually a second workflow as well. Orders themselves are actually stateful, so I've turned those into a cadence workflow as well. So for the orders, the order starts, it generates the location where it needs to be picked up from, it gets ready for the drone to come and pick it up, it updates the locations continuously based on the drone location, and then essentially if it's delivered correctly, then it ends successfully at the end. So because we've got two workflows, we actually need some sort of coordination between them, and this is an example using one of the primary mechanisms in cadence, which is signaling. So it provides a built-in mechanism for asynchronous signaling between workflows, which works really well when you've got multiple workflows that need coordination like this. Okay, so just to make things a bit more fun and perhaps realistic as well, and because I like Kafka, I introduced Kafka into the architecture. So cadence meets Kafka. Kafka, for those who may not have come across it, it's pretty common now. It's a distributed pub subsystem for stream processing. It allows distributed producers to send messages to distributed consumers via a Kafka cluster, and it uses topics to loosely couple the producers and consumers. So I integrated that cadence architecture with Kafka, and this adds basically a cadence cluster with 3 Kafka topics, 3 Kafka producers, and 2 Kafka consumers. And what you can do essentially is start a workflow from Kafka. That's the second star up there. So we're actually using Kafka to initiate the cadence order workflow. And we're also using essentially a Kafka microservice to coordinate drone and order workflows. So this is where you can actually make sure that the drone picks up only one order and that all orders are actually picked up. So that was quite a good use case for Kafka as well. So just showing more or less how the system works in its entirety. I'm just going to go through a few steps here to see what's going on. So first of all, the customer places an order with some sort of an app or something. The order is sent to Kafka to the new orders topic. Step 2, the Kafka consumer gets the order. It starts the new order workflow using a cadence client. Step 3, the order is ready for the drone pickup. This is basically an activity where it sends the order ready message to the orders ready topic. Step 4 is, again, back in the drone workflow. It's an activity. It sends the drone ready message to the drone ready topic. The Kafka producer gets an order ID and sends a signal back to the drone and starts the order pickup. Step 5 is in the drone workflow. It flies to the order. So that's, again, in an activity. It flies to the order location and picks the order up. Step 6 in the drone workflow, it flies to the delivery location, and that's in an activity as well. It flies to the delivery location and hopefully does something else. Yes, okay. So it flies to the delivery location, drops the order, continuously sends location updates to the order workflow within seconds so that the order itself knows what's going on. So the customers potentially can get an ETA for the delivery and check to see where on a map their delivery is, and also so that the shop that supplied the order knows what's going on as well. Step 7 in the drone workflow, it flies back to the base again. So once it's flown to the delivery location, it flies back, it recharges when back at the base, and is ready for starting a new drone workflow. So in fact, the drone workflows are never ending. They actually use a particular mechanism in Cadence, which essentially allow them just to repeat. So they actually are more or less permanent workflows at that point, whereas the order workflows do actually end. Step 8, back on the order workflow side, it receives the update location, so that it receives the state and location signals from the drone workflow, updates the state, and finally, if successfully delivered, it actually ends the workflow. And that's it as far as the architecture goes. So one thing I'm really interested in is performance and scalability, and that's one reason that you'd use Cadence, is because you'd need lots of workflows. So I did an experiment to see how many drones, simulated drones again, we can actually fly at once using this particular cluster. It's not a particularly big one. You can scale the cluster out horizontally in any direction you like. What have we got? We've got 6 virtual CPU cores for the Cadence part of the system, 18 for Cassandra. So you can see Cassandra is actually the part of the system that needs the most resourcing. And on the client code side, running on some EC2 instances, that was 8 virtual CPUs, giving a total of 32 virtual cores for that system. And with some load testing I did, we managed to get 2,000 drones running concurrently, which also means you've got 2,000 orders concurrently as well, which gives you a total of 4,000 concurrent workflows running with that system. That's not a particularly big system. You can easily scale that to hundreds of thousands. And if you want to find out a bit more about Cadence and other open source technologies, there's my URL for my blogs. I've written about 100 blogs in the last 6 years on open source technologies. This is just the latest in a series of interesting technologies I've had to learn and demonstrate. And with a bit of luck, I think I've got an example here. So this is where I live in Canberra. I've assumed my backyard is the drone delivery headquarters, the base where all the drones start from. And if I'm in luck, I'll be able to set it going. And essentially the orange icons there are where the orders are being picked up from. The moving darker colors there are the drones. So they go and pick up the orders from the shops. And once they've done that, they then head off in a different direction to the red icons, which is where the delivery locations are. And this is only, I think I've only used 20 drones in this simulation. And this was done actually using JavaScript in a browser, subscribing to a Kafka topic that actually had all the information about the drone locations and other information that it needed to generate this interactive map. So as the drones pick up the orders, the orange colors disappear. They're not really interesting anymore, and they head off. So that one's about to deliver an order to a particular location. Once it's done that, the color of the icon changes and it heads back to the base again. So that'll run for about another couple of minutes. I'll take any questions perhaps at this point while that's still just going on in the background there.
Thanks a lot for the talk. I'd just like to remind the next speaker, I think Jiang Shen, if you could start getting your laptop hooked up for the next talk, because there was a little bit of delay this time. Yeah, please go ahead. Thank you very much.
Okay. Any questions at all? I must have explained everything you need to know about Cadence. That's good. Cadence there's a lot more to it. It's a great tool for developers. So if you are interested in building complex workflows that are scalable, have a look at it. And it's all open source and all very developer focused. So yeah.
I have a question. I know you have Java and Go support. Do you have any plans for Python support?
Yeah, look, I'm not one of the actual developers of it, but we do work with the development team quite closely. And from memory, I think Python is one of the supported languages that's not really officially supported. I'm not sure if there's any plans for any other languages at this stage. So, yeah. Is it finished it? No, it's still going. Yes. This is sped up, by the way. It actually takes about half an hour for each delivery. They go at about 100 kilometers an hour, the drones. They're really annoying. They go,
Did you add your own address as a...
Oh, yeah, it is. No, well, no, because, no. But I am the sort of the drone lord at this point. I've got the base in my backyard, so, yep. Yes. All right, I think that's all from me.
Up, we have Jingxiao Liu. He's principal engineer at OpenEuler. And he's talk.
Okay, thanks for your time. Today I will go to share this topic. First, I will tell you some keywords. The first keyword is Rubik. It's a new open source project. And the second is QoS guaranteed for containers. Okay, Okay, let's continue. And before my sharing, I want to share you with OpenEuler and myself because I think they are very important as my background. Okay, the first one, OpenEuler. It is an innovative open source OS and covers all scenarios. That's our vision. And it has many innovations on Linux kernel and it is a solid cloud infrastructure. Currently, it is incubating and operating by the OpenAutumn Foundation. That's OpenEuler. It's an OS. And the second, myself, Jin Xiaolu, currently the project leader of Rubik project. And my focus is on container infrastructure and in Linux. So we have a connection on OS. So I will try to explain this topic, CPU utilization, from the perspective of OS. Okay? Why the resource utilization in data center needs to be improvement? As you know, our data centers are growing rapidly. That's why we have many data centers building every year. Then you know that the CPU allocation or reserved for the customer are very high in the data center. But if you check on the monitor system, you will find that the actual CPU utilization is low, maybe 10% or 20% on average. So in industry, we are trying many ways to improve the low CPU utilization. Okay. Currently in the container world, we are trying this co-located deployment to improve. Okay. Before that, we are in a siloed architecture. That means we have many different kinds of workloads, AI application, big data application. They are deployed in different resource pools with different software stacks. Okay, in these years we have Kubernetes. Okay, and most of our applications have already containerized and can be scheduled by Kubernetes. We have a unified cloud infrastructure these years. Okay, that's the basis of our today's topic, Kubernetes. We have a unified cloud infrastructure. Okay, and as this S to B, we define different stages for this evolution stages. The first one, level 0, independent deployment. That's the as-is stage at the last page, and the level 1 to level 4 are different stages at this 2B. Okay, that's something different between those levels. Okay, the first one, level 1, we define as shared deployment, and level 2 is hybrid deployment. The difference between level 1 and level 2 are we are already in the same software stack and share the same resource pools. The service type in the resource pool may be different. Okay, on level 1, maybe we only use the software, but the service type is only one. Okay, and next in the hybrid deployment we have multiple service types. But at level 3, okay, at level 2 we selected the different kinds of service types in the same cluster. But at level 3 we hold that all workloads are deployed freely. From the OS perspective, we hold it is in the black box state, which means that we at the OS side, we have to detect which kind of workloads it is as a black box. Okay, level 4, we hold that it is in the whole multi-cloud deployment. We have a technology to schedule all kinds of workloads in all clouds to improve the whole CPU utilization. That's our different stages. Okay, based on the functions needed for the OS, I have listed many. Okay, those left part are for our operating system. We have multi-level resource isolation from level 1 to level 2. And from level 2 to level 3, they are QoS scheduling or quantification, interface control, or to level 4, the built-in capability. Okay, there's some key functions, and I will try to explain or introduce functions to you today. Okay, we have these functions, and we have this architecture. On the other part, upper part, they are Kubernetes in this cluster. We OpenEura as a work node is located in lower part. It is built on Linux kernel, as I mentioned before. Then the Rubik is run as a set in this Kubernetes cluster. Okay. It provides the different kinds of in here. That's our architecture. You can see that in this timeline, we have finished part of them, and we'll try to build more on this next year. Okay, that's our architecture. From level 1 to level 2, as I mentioned before, we are trying to build this multi-level resource isolation. Okay, why this it is not needed? Once we build this hybrid deployment for containers, they must based on a consumption that our workloads will be deployed with multi-level priorities. Okay, we have different priorities for those workloads. Okay, to simplify our modeling today, we called it, we divided it to two. One is on service, and the other time is offline service. The online service, they are sensitive to QoS and latency. Maybe they are for short time learning, and the offline service, they are offsite. Okay, so there are some difference on these services. So we define the different kinds of resource isolation capabilities for those workloads. As you can see in this table, we have CPU queues, memory queues, cache queues, network queues, and these queues. Okay, we have built such technologies, and they are all already open source in OpenEura. Okay, I won't share all of them today, but try to introduce 3 of them. They are our elite features. The first one, as I mentioned before, we have online and offline workloads, and normally the online service needs more CPU resources. And in our Linux kernel, we are using this CFS scheduling algorithm, and CFS is a fair scheduling. Okay, we cannot have a bias on online service and offline service, so we add this multi-level preemptive scheduling to CFS. So once the online service wants the CPU resources, we can suppress the offline tasks to obtain the CPU resources for online service. Okay, this is the first feature. And the second one is multi-level load balancing scheduling. Load balancing. Okay, and it is because once this online service is running, we may have many idle CPU cores. At that time, we can load balancing those offline workloads to the other CPU cores to decrease the number of tasks, context switches, and migrations. Okay, that's the first and second features. They are both on the basis of hybrid on online service and offline service. what about if we have a hybrid deploy with online service and online service? Okay, based on the characteristics of online service, it will normally apply for sufficient resources. Okay, that means we will have low utilization on CPU at most of time. So we try to build this dynamic core affinity feature to try to overcommit CPU resources in C group. Okay, that's the features from level 1 to level 2. And welcome to level 3. Okay, level 2, as I said before, okay, we are using the customer selected workloads to deploy in the same cluster carefully. Okay, in level 3, we have a such mission that we hold the customer can hybrid workloads freely. As a black box from our OS point of view, so we build such method with offline training to get a model on such specific online workload. And we can use these models for our prediction on live network. Okay, for online training, we try to run this online workload in the test bed. We have different kinds of magic collection from Linux kernel or the hardware. And we run this online workload in high pressure. And then at the same time, we stimulate different kinds of pressure to this online workload and capture all kinds of interference is suffered. At that time, after the testing, we analyze these interference and the QoS of this online workload. We can get a model. Okay, then after many testings, we have these different kinds of modeling for our latent online prediction. After that, yeah, we have this library as I showed here, and then we have hybrid deployment with online services and offline services. Then we have this Rubik learning as a demo. It tries to collect all kinds of metrics in the background and does many kinds of quantification for its QoS and analysis interference for online services all the time. Once it has got any kinds of interference, you try to locate the source of interference. Normally, they are from offline service. So if we located those interference from offline service, we can try to control it by everything those offline services to another cluster or another node, okay, or separate state for this kind of CPU resources. That's online prediction. And level 4, remember that we in level 3 we are deployed in one cluster or one cloud. But at level 4, we hold that we can use multi-cloud or multi-data centers. So the customer may face one scenario. He has a pod, requests CPU pods, CPU cores. He may get different computing capabilities among different clouds, which increases his management costs because he has to maintain different configurations in different clouds. Okay, why it has happened? I listed the possible reasons. Maybe it is by different generations of processors or different architectures of processors, or maybe they are using the same processor but with different configurations, such as HT or frequency, or different kinds of frequency. So we propose this idea. Can we unify the computing capability for this processor or for this physical server? So in our Linux kernel, in OpenEULA, we try to normalize the computing capability. And in Rubik, we try to conversion this capability to a unified NCU that's normalized computing unit for the easy management of this cluster, okay, for scheduler. Okay. That's all key functions we define for this utilization. For your easy using, we recommend that you use Rubik. It is a bridge connects our cluster, Kubernetes, and OpenEULA. It runs as a demo set in Kubernetes cluster, okay, in the work node. You can quick experience it with this. First, you fetch its YAML, and then you apply it on the node. Then you can integrate it. For more details, please visit our code repo. Okay. This is our first case. We already use our technologies in our internal cloud platform. In the sample cluster, we have already reached 70% CPU utilization. Okay, this is case 1 and case 2. Our community friend, 新浪微博, they already use our features in their live network in production. They already reached 60% more CPU utilization. Okay, this is our cases. And what's more, we recommend that you use Volcano and Kamada for more cluster features. As you know, for this CPU utilization, we are talking the whole data center or multi-cloud. But on OpenEULA and Rubik, we are based on the only specific node, okay? If you are going to the cluster or the multi-cloud, we recommend that you use Volcano and Kamada, okay? Welcome to JS. We are learning to cloud native SIG and Isla in OpenEULA. And Isla-D is a lightweight container engine we developed in OpenEULA. And welcome to engage us. Thank you. That's all for today.
Thank you very much. Do you have any questions?
There was one slide about Rubik,
Yeah.
and at the bottom there was the frequency scaling.
This one? Yep.
So what does Rubik give me? It gives me like a unified explanation of how much compute I get from that particular system.
Yep.
How does this translate to the CPU utilization? Because, for example, if I take the frequency scaling, right, and I enable the low P state, P0, just by having it enabled, whenever it goes into P0, just randomly I lose like 50% of the performance, and I add a bunch of latency also on network, even if it's not really sleeping, right? But how does what does Rubik do in this case?
Yep.
Or
This is a good question. Okay, the first thing, we are still trying to develop this feature, maybe on the late of this year or next year. Okay, and what we're trying to do is actually we are only focusing on the CPU resources now. So the first thing we are trying to learn a micro benchmark on Linux kernel or on the Linux. We try to test the capability of this CPU. Okay, we got a score for this CPU. Then we unified in Rubik. After that, we can get a result maybe from 0 to 100. It's a score for this CPU. Then propose to the custom scheduler. Okay, at that time, it may introduce a confuse to the customer because normally in our for our daily use, we configure different CPUs for our apps, okay, or for our container pod, maybe 10 CPUs. If with this one, maybe there's a number, but not the CPU cores you configure. But with this number, maybe you can get the same computing capabilities in different clouds. That's our reason. Any more question? Yes, we're trying to define a small benchmark to test the capability of physical CPU. Yeah.
Great talk, thank you. My background actually is performance engineering. I spent maybe 30 years doing this sort of stuff in grid environments. So
Yeah.
I don't know if you have much familiarity with some of the earlier grid computing,
Yeah.
resource scheduling stuff. This is quite close.
Yeah. Yeah. Yeah.
Maybe you might pick up some points, but this looks really interesting. I mean, so you're only trying to optimize, you're not thinking about I/O and networking as part of the problem at this stage?
Sorry, I didn't hear.
So you're focused on CPU rather than I/O, which is also another resource in a
Yeah.
cluster, and networking, which is also another network bandwidth, which is another resource that you might find challenging at some point.
Do you mention this one?
Yes, okay. Make this guy I/O as well.
I didn't prepare the PPT for this feature today. Okay, we are trying to use the EDT and eBPF in Linux and try to how to say just with EDT and eBPF and has a small config in the user space to control the network bandwidth. Okay, I think it's hard to describe it. Maybe I can show you something later. Okay. Sorry.
How are you building the model of the system and resources? Are you using some modeling language or tool?
Is that this one?
Yes, so what does the model look like?
Okay, we have this also is still based on the OS point of view. What we can see is different cases of resources such as CPU, cache, and memory. Different kinds of workload, they may, maybe I can take an example of Nginx, okay? Nginx, it is most of the time it is only using the CPU. Okay, so it have a specific model. Is it has a high CPU usage. Okay, but it didn't sensitive to other resources. That's kind of CPU sensitive or CPU intensive workload. Yeah, that's one kind of model. Okay. And such as we have many, we can define different kinds of models, maybe network intensive model or such as. Thank you.
Thanks again for your talk. Our next talk is going to be at 11:15, so we have a little bit of time. But Heath, you're here. Are you? No, sorry. Is Heath here? Yeah, he's not. But we'll. Hello, yes. Getting ready to start our 11:15 session. Just a reminder that we are streaming, so we're streaming on Facebook and several other platforms, so this is going live. Our next talker is Heath Newburn. He's the field CTO from PagerDuty, and his talk is Safely Delegate Your Cloud Operations with Self-Service Automation. This is a 25-minute talk.
So, gosh, that's loud. Sorry. So as Ryan said, my name's Heath Newburn. You may be wondering why PagerDuty is talking about Rundeck. Anybody wondering why? Because we own it. So that's one of the things a lot of people don't know about. If any Rundeck users here today, cool. We're going to make you Rundeck users before this is over, right? So Rundeck, freely downloadable, open source. PagerDuty, we've acquired it as part of our core capabilities, and we've really built our entire operational stack around it now. We're pretty happy with it. So that's what I do. So field CTO, my role is really to work with clients around the world on how do you take your existing investments you have, how do we do things around helping you build out your automation capabilities, your AI ops capabilities, your incident response, automated incident response. And so really what I want to spend the time with you today on is kind of some of the problems that we're seeing out in this space, in particular around cloud, right? And we think about cloud automation and what that actually means for us. What are we actually really trying to accomplish? Is, there's certainly, we've all heard and understand the easy promise of cloud, right? Very easy scalability, great. Happens to also then lead to, really remove those very easy barriers. So now you say if I started a company right now, I would never rack and stack that first server. Of course it'd be cloud, right? I'm assuming most of us are all in cloud. Everybody on cloud, we're not out in the wilds. And the whole idea behind that was supposed to be happening is lead to increased business agility, right? So here's a hint. When you're talking to your bosses about your next set of investments, don't talk to them about speed. Don't talk to them about, hey, the cool tech. Talk to them about how it's going to deliver faster, how it's going to make money flow faster, right? I love our business folks. I really do. We have an amazing job. We get to work on cool problems, do cool stuff. we really suck at telling our own stories. Right? How do we begin to do that? So as you begin to look at these processes and the things you want to think about and things you want to do, think about it in terms of what does that mean for business agility? How is that going to allow you to deliver faster? And whether you want to get into the business of creating disruption, whether you want to be smart about things you do, whether you want to create efficiencies, this is the whole promise that we're doing at. But, where does this lead us to? Well, it also turns out that when we make things really, really easy to use, anybody ever gotten your bill at the end of the month from Grab and realized you spent way too much this month? Because it's got real easy now, right? Don't want to leave your room, don't want to leave your house, don't want to leave your desk. Next thing you know, you're up $800 on Grab. It's easy to do. So we make these things so simple, so easy to consume, that things like surprise billing turned out to be a real problem for us, right? Fair? We also end up, when making these our cloud pieces work, end up with a lot of architectural complexity, right? Because no matter which part of it, whether we're in Azure, whether in AWS, right? Think about all the components that I'm going to have around RDS and my Route 53 and all of the other pieces that are required in order for me to build these complex applications around that. I'm putting Docker in, I'm putting Kubernetes in, right? So the things that we're asking people to do now are becoming more and more complex, right? Anybody here part of an SRE team? DevOps, we finally got SRE. Rock on, my friend, right? We see a lot of organizations are moving to SRE, but here's one of the things about SRE is that we demand an awful lot from those teams, right? The expectation is the whole stack, down to the infrastructure level, right? So all of those things that are going in that, require a lot of things. And so what do? Well, we end up then wanting to figure out the right tool for the right job. Guess what? There's an awful lot of right tools for an awful lot of right jobs. So this is one of the things. I always hear people talk about, cost and these other kind of complexities when it comes to cloud management. We don't talk enough about tools complexity. We don't talk enough about how hard these things start to look when we gather all of these additional pieces of information together, right? Because, we stand these up. Our database people want one set of management stuff. Our network people want another set of management stuff. Our core infrastructure capabilities on how we're going to drive our OS, our virtualization, our Kubernetes, our Docker, are all demanding other pieces of that, right? So what we end up with is a massive amount of tool sprawl that we have to begin to think about, is there any possible way we can begin to address this? And think about, what's next around this. So what we end up with is a set of capabilities that, of course, because we look at this as a purely technical problem, when we think about this technical problem, we want technical solutions. So we want developers. So in this case, you can see some CloudFormation stuff down there for my friends that love CloudFormation. It doesn't matter. This could be Harness, Pulumi, Terraform. The whole idea is we're going to deliver things as code. But here's kind of the thing that's happened now is with this promise of cloud is where the expectation is anybody can use it. Anybody can deliver value from it. Anybody can create this. Yet we've kind of created this temple of high priests, you in this room, who get access to things, but who else does? So we demand this level of familiarity down to the code level on how you want to look at and create these values from that. So what we end up with then is, with this temple of high priests, what happens? Anytime you want something done, you have to go to the high priest, right? That means that if I'm a business leader sitting out here, hey, I've got this great new idea, I've got a new client, they're willing to pay us a lot of money, I need you to stand up my next instance of this database that I'm going to come out, it's going to be part of the billing thing that's out there. I got to come, how many requests am I going to put in? Right? I'm probably going to go put in some core infrastructure requests. I need somebody to stand up some additional billing. I need somebody to come up and instantiate the piece between them. I need virtual. And it goes on and on and on. Is anybody ever have to submit those kind of requests? Wait for somebody to come back to you to give stuff to you? Right? We see it all the time, right? And here you are. This whole idea was cloud was going to make it easy. It's going to make me go fast, right? I was actually working with a client in the West Coast of the US. They put in a request to just simply extend the monitoring in their environment. 4 months. 4 months, right? Digital business, moving at digital speed, 4 months. It's too long. Why? Because so few people have the understanding of the end-to-end pieces on it, right? On how we begin to drive this focus and think about what we want to do. So the other part is we get interrupted, right? So if you're on the other end of that request, you're the one receiving all these requests. It's awful damn hard to get work done because it's this constant interruption, right? We call it unplanned work. There's a fantastic book, by the way, if you're actually having, want to be able to better communicate with your senior leadership on why you can't get your job done the way you want. Fantastic book called Making Work Visible. And in Making Work Visible, they talk about how do you begin to surface all of this unplanned work? Where do all these interruptions come? Hey, why can't you do all the things that you're supposed to be doing? Well, it's because I'm running around putting out fires all day. It's because I'm running around constantly, asking, standing up individual pieces of stuff that's this toil that's sucking up all of my day. So I need to get a lot smarter about how I do that. So I want you to think about, that interrupt-driven piece of it. What is that costing? By the way, worldwide, unplanned work cost $1.1 trillion to businesses across the globe in 2021. So affects a lot of us. So how do we begin to rethink this, right? How do we begin to think about really getting this, this overall promise of cloud that we were all supposed to have and make it so easy on us? And really, bless them, but how do we reduce the burden on these business users that are asking these things from us? What does that begin to look like? We need an easy button, right? We need something that, how can I make it very, very simple for people to take and consume the services that I want to be able to give them? The cloud was going to tell us, we just go ahead and snap these things in place, you put it up, you're ready to go. So how do we begin to do that? Well, Rundeck. That's my presentation, thank you. Sorry. What's the idea behind it? I want you to begin to think about self-service operations. What does that begin to look like? How do I begin to make it to where I can stand up easily accessible, readily addressable, secure, role-based access controls so that anyone in my organization can make it very simple to get access to the services that I want to deliver, to be able to utilize those cloud resources in a way that makes sense, and allow the experts in the organization, all of you, to be able to design things in a way to say, hey, here are the things I want to easily expose. Where are the things that I'm actually spending too much time on? Where are the pieces that are actually making me lose focus on day capabilities and what I want to do? So if I can begin now think about making it very easy to self-service, what begins to happen? Well, number one, I'm going to enable everyone in the organization, right, on what I want to be able to do. And I'm now going to be able to have a secure methodology, right, so role-based access control. My dear friend Keo over here, Keo, raise your hand. One of the smartest people I know at PagerDuty, really smart dude, knows a lot about this stuff. You can go find him in the booth later on if you want to have some more questions. But I want Keo to be able to do anything. Keo gets it all, right? My dear friend Adele here, also at our booth later. Adele is going to be really, really good at networking. She gets to have all the networking stuff she wants. The woman will not walk near a database in my organization, I swear to God, right? Can't have any of that. So very, very easy to begin to segregate the kind of requests that I'm going to be able to drive and do at component level, right? So how I want to do requests, how I want to tie things together, how I want to drive pieces through that. And here's what gets really interesting, that this use case actually becomes generic very, very quickly. I could think about holistic service request management as well. Because I've actually created a methodology for how I'm going to secure access to things, right? So I need vaults to contain, secrets and passwords and keys and things. I need to be able to have a way of how I do define role-based access control across the entire organization via SSO or whatever else. I need to be able to have a way that I can, catalog and segregate various disparate pieces of things with tagging, that sort of thing. And I want to make it very, very easy to run. So those are the pieces that are put in place. Once you've actually deployed Rundeck, which is OSS image, you can go out and download it today. We actually have, full licensable versions of it as well. But, when you get it, great, you unpack it, you stand up your cluster, now what? Well, first, what are your most manual and repetitive tasks? And I know that sounds a little silly, right? But bear with me for a second. I want you to stop and think, and here's a thing now, because everybody's already got automation. If I were to ask you, do you have automation, anybody that doesn't raise your hand is a fool. Because you've got it already. It's just that today, it exists out in his share drive. It exists out, on his laptop. It exists out on that local server over there. It's there, but we haven't found any way to actually bring it together. So go find that stuff, right? Hey, when I send you a request to go ahead and add something to a database, what commands are you running? What scripts do you already have in place? What Python have you already written, right? And let's go reuse that. because this is what's key. What I find with automation isn't that anybody believes that we don't want to automate. Everybody wants to automate. That's not the issue. It's a question of being able to make the time and the commitment to do so. Are you able to actually articulate a return on investment for that automation and things you do? Beginning to think about this in terms of dollars, not just in terms of technology. So starting with those things that are good. You know, I want to be able to take all the existing pieces. I don't want to rip and replace anything. The second you start a conversation in your organization of, hey, I got to go rip that out of your PowerShell, you're done, right? Because I've got those investments. I don't want to lose those. I don't want to go rewrite stuff. So how do I do that? I talked about this operational framework of how do I begin to think about how I want to solidify? What does that look like? How do I want to get down? What level of fine-grained access control that I actually want to do? And then beginning to think about how do I design that various user experience, whether they are, hey, they're other developer peers of mine that don't happen to have access. They're actually maybe on-prem, but need access to, to cloud resources for hybrid environments. Or maybe they're AWS engineers, but I'm doing something out of Azure. Or maybe they're just straight up business users that you need to be able to take a product manager in your organization and give them a way to communicate with you what their needs are to those next set of capabilities. Because here's the really interesting part of this, folks. We have a credibility gap in IT because we have a visibility gap. We are the moles and trolls in the basement. Because think about this for a second. If you do your job every day, dead solid perfect, you make no mistakes, no errors, 100% availability, does anybody know you exist? You're completely invisible, right? So this is a way that you can now, one of the very first times, show, hey, here's what I can do for you. Here's the things I can provide. Here's the value I'm driving for the organization. Here's the dollars I'm pumping into this value stream around the things that you do. So begin to think about how do you want to go to the stakeholders that carry an organization to surface to them all the hard work you do. Because we don't get enough credit. We get the blame, right? Think your last outage, everybody could find you then, right? But the last time something went right, last time you were up for 30 days, anybody pay attention? No. So begin to think about what does your journey for automation look like, right? So, obviously all of us kind of are on the manual piece of it. That's pretty straightforward. And, and that doesn't necessarily mean anything bad. It just means that there's probably a lot of toil we could begin to think about how do we remove it from the organization and what I do. We've kind of kept automation to, the high priests, very limited. We want to make sure that we, allow people to see the things that are there. So I want you to begin to think about what does that first move to, reactive or responsive look like, where, I'm kind of doing some, fairly straightforward ticket handling. I'm beginning to think about how I move things to the system a little bit easier. I'm beginning to set up automation for experts, repeatable sets of capabilities around the things that I have. Then this is where I get, a lot more interesting. So when I start to get more responsive, this is where we're getting to standardize. And that's really the big key to automation, is standardization. How do I make it repeatable? How do I create templates that I can hand to you, whether they're Terraform, whether they're Harness, whether they're Pulumi, whether they're something else, that I can say, if you want to be successful, if you want to work with me, here's the easiest way to do it. And then proactive. This is where things get much more interesting, because automation today in your environment is driven in two ways. It is driven by a human initiating it, right? Which all that means is you still need a person like you that's smart enough to know which particular script to go run, or it's run by a schedule. What if instead it's event-driven? What if now I go ahead and get a request from a product manager saying, hey, we want to spin up this new piece of it. It drops that into a pub sub. You yank that off. Know that your automation then says, hey, here's the next things I got to go fire in order to expand these sets of capabilities, and begins to deploy, right? Where now automation is an extension of my observability pipeline, an extension of my CI/CD pipeline, and an extension of my service request. Now we're doing something really interesting, right? And this is not rocket science. I know this seems, if you're just kind of over here right now, it seems way, way, way far away. Turns out it's not. It's actually pretty straightforward. My friends down there in the end, come see them at the PagerDuty booth and they'll show you, right? So this is what what we're really trying to get to is, we're talking today primarily about, what are you doing on being able to automate these service requests? And because my whole goal is, I want to get you out of your home office onto your home back deck maybe an hour earlier this week. It's great that we can do things that are for the company, but I'm not looking for us right now. This is what I want you to think about. The investment in automation isn't so much about, hey, how can we create more value for the company, which is great. I want to create more value for us. Because again, we don't get enough credit for the things that we do. And also beginning to think about what is it now, because we're talking about basic cloud capabilities, but guess what? We got to run those clouds. Same kind of thing today. Who's actually on call right now? Rock on, my friend. Thanks for being here anyway. I appreciate you. Right? On-call is pain. On-call will always suck. There's nothing good about being on-call. So, friends of yours, if you've got friends that are on-call, give them an extra hug. They need it. Buy them a beer later. They absolutely need it. So how do we begin to think about what does automation begin to drive in on-call? Well, if automation become the first virtual responder, guess what? My dear friend in the back maybe gets 10 less calls this week. That's a pretty good deal. So beginning to think about what does this system of automation begin to drive for us? It not only gets us our own hours back, it can give us the capability for actually increasing overall availability. So think about what does that journey to event-driven automation look like, right? Think about how do you begin to peel off the pieces out of here to get you to here, where you've got happy, smiling folks that it's a whole lot easier to do business with. People know what you do. You're saving time, you're saving money, you're delivering faster, and you're getting that garbage out of it. There's a lot of great stuff in the things that we do. Did anybody get into IT to sit at their keyboard and run commands? I didn't. We get here to solve cool problems, to do interesting things. So let's figure out where are we wasting our time? Where are we not doing interesting things at? And go automate those things that are there. So that's it for us. We've got the PagerDuty booth downstairs. We're at the very back. Make the trek back there. Come and see us. I'm sure we got some swag and other things that are there. We can walk you through kind of some more examples of this, talk about some specific use cases that would be useful for you in your organization. And I guess I have a couple minutes for questions, right? So everybody bought all of that. Yes, sir. So the question is, can you use it to where it's like an L3 capability to where it would actually try and resolve the issue first, as part of the overall process automation, correct? So yeah, let me answer that in two ways, right? So there isn't an inherent ability inside of like the Rundeck OSS to drive events associated with it. However, as part of a whole page, yes, it is. So the idea is that Datadog, New Relic, AppD, Zabbix, your favorite monitoring tool raises an alert, right? A threshold's been violated or a transaction is now trending off. I'm going to send that alert. We're going to take that alert, normalize it, send it to Rundeck. Now, the only thing I'll caution you on is what I would say is, yes, if there's an available, what I like to call sort of horseshoes and hand grenades fix, right? Can I make it, can I pummel it back into submission, make it work? Yeah, absolutely. But what I really want you to think about is, what if I actually focused on doing automated diagnostics first, right? Right. Yep. Yep. Gotcha. Yeah, so you can do that basic reflex action, like you can do a webhook out of a Datadog or something else that'll do those attempts. When you actually drive into this, what we do is we build more complex workflows that will say, go ahead and capture the diagnostics first before you attempt remediation. Because to your point, if I've tried it 4 times and it's still failing, I would really like to know why, right? And even if I do get it back into a working state, I would like to know the failure conditions. So our suggestion is inside of Rundeck, you would define the automated diagnostics first, then begin to attempt remediation, like you said, inside of a try loop, in being able to identify I've got multiple failovers. But you think about the kinds of remediation you could do. So for example, by leveraging a more complex automation instead of a webhook, what I could do is I could say, hey, let's say I want to fail over a cluster, but I could actually check the health of that cluster first. And if it's a 4-way cluster and I've already lost 2 of them, I don't want to fail over, right? Because now I'm down to a single point. So I can begin to think about remediation in much more complex ways than what I do. So we start with, to your point, failing over a cluster, then we build to, instead capture the diagnostics for it, then attempt the failover only under certain conditions. But yeah, that's exactly the direction that we're headed and what we're trying to do. That help? Yeah, and that's what kind of best in breed. I've got clients in financial services in the U.S. that be able to drive down their MTTR for their Nginx clusters and their web server clusters down to 60 or 90 seconds because of these kinds of complex methodologies in Rundeck. Exactly what we're doing. Other questions? All right. Like I said, I'll be around the rest of the day. My friends on the PagerDuty booth. Look forward to seeing you all. Thank you guys so much for your time and attention today. Appreciate y'all.
in cloud. This is a 20-minute talk. And just a reminder that we're streaming today.
Check, check, check. Yep.
Hello, check it. Perfect. Hi, good afternoon, everyone. I know the next one is we are going for a lunch, but I'll make more interesting. Don't worry about it. I'm Bhuminathan, and thank you for the quick introduction, Ron. Right. So currently, I'm helping as a Cisco multi-cloud architect, multi-cloud, regional multi-cloud architect, helping Cisco solutions on hyperscalers like AWS, Azure, and GCP. So what is the experience I'm bringing here, right? I have nearly like 2 decades of experience. Maybe like 12 years before, I did a cloud, meaning when AWS saying auto scaling EC2, by the time itself, I did a project. So that's my one of the biggest advantage. So I did like a lot of cloud migrations and cloud modernization and app modernization. These are the things. So apart from my current role, what I'm doing is I'm also doing a lot of
organizing a lot of community and also talking a lot of the global conference. For an example, yesterday I was part of API Days delivering the talk and also the Kubernetes user community. So I love one thing about myself is I curious to learn and share the knowledge. That's about me. And apart from the technology, I also do mentoring. If you guys need any mentoring, I used to like walk, you can connect with me. And this is my LinkedIn. At any time, you can connect with me. And I have certified in multi-cloud. Well, that's it. Okay. Now, let's come to the actual topic. Okay. As I told you, I want to be more interactive. Okay. How many of you guys already architected your applications in the cloud? Awesome. So, well, maybe I wanted to ask from Rain. So, what is the application you architected? And what are the high-level key pillars maybe you considered?
We have an ML application.
Oh, awesome. That's great. So what are the key parameters, kind of like a key pillars you consider while you do the architecture? Traffic. Perfect. Okay, because it's kind of like a machine learning, compute intensive. So you need to be like a network, how the network intensive there. Those port is like high bandwidth available or not. Perfect. Maybe I'll take one more question. What kind of application you architected? Is it like a data center migration or like any specific application? Contact point. So any key things you consider like while doing the architecture? What was the like a push? What I'm asking is, what is the business push and what is the technical push doing the architecture? Visibility of the infrastructure. Reproduce. Yeah. Okay.
We want to be able to deploy.
Got it. Immutable. Okay. Awesome. Okay. Elastic. Okay, awesome. So I'll just like summarize, right? What Ryan says is Ryan focused more on performance efficiency. That's his key thing while doing the architecture. Whereas, may I know your name? Sorry. Hardy. Okay, Hardy says more on operational excellence, how it can be like reimmutable, kind of like how I can do that. So for sake of understanding, I'll take only AWS, how you can do the AWS architecture in any that's common for Azure or GCP or Oracle, anything. But for the easy understanding, let's take the AWS. So there are like 5 key things we need to make sure while doing any architecture. First thing is, as Ryan mentioned, performance efficiency. How our workload is going to deploy in the cloud and going to operate in the cloud. Because at the end of the day, we are architecting for the applications. Applications is nothing but the business outcome, right? So the business needs to run, it has to be performed efficiently. So that's why like you have to select the proper compute, proper network, proper storage. If you remember the Rain word, he told it's a compute intensive application and network intensive requirement, like high GB, those kind of stuff. But if you see Hadley, he told it needs to be elastic. That's where operational excellency comes into the picture. So most of you guys come from like a DevOps or platform engineer or SRE. That's where like operational excellency. Okay. The third one is maybe before instead of I say I want to hear from you. We talked about 2 things: operational excellency, performance efficiency. So other than the 2 key pillars, anyone wanted to share any of other key pillar which you did architected? Sachin, you wanted to share? Yeah. Okay. Okay, got it. So Sachin concept is cost optimization. See, so we are always doing the architect for the business push. So business is always like what's the cost benefit? What's the cost optimization? I can do that, right? So this is like a third pillar, cost optimization. How do we do the cost optimization? So that's where we have to use the latest, an example, where our infrastructure is running, more on the compute instance. So we need to use the latest one. Then we have to use more kind of like a latest technologies like a cloud native kind of containers or serverless, those kind of stuff. So you guys only shared 3 key pillars: performance efficiency, operational excellency, cost optimization. I told you like a 5 key pillars in architecting anything, and I wanted to be more interactive. There are 2 things remaining. Anyone wants to touch base? Just think from your own experience. What does it matter for your organization? What does it matter for your customer while architecting any application? SLA, that's good, cool. Exactly, that's a 4th thing, security. Because why we are consider we are architecting an application, if the application or is not secured end to end, how our customer can deploy that? Okay, or like how we can deploy our BFSI or like banking applications on the cloud. So security is the key pillar. Okay, this is the 4th one. The last one is the last one is before I complete the last. Okay, the last one is reliability. Okay, what is reliability? See, I'm talking now. We are connecting all the ways, like in person, also online. Reliable, right? Like if anything, if you guys miss it here, some of the people can hear from the online also, and it's available at recording also. Reliability comes from the resiliency. Okay, it has to be available all the time. And if you remember the famous quote from AWS CTO Bernard Works, everything fails all the time. Okay, so the reliability. So let me summarize what are the 5 things. Okay, reliability, performance efficiency, operational excellency, cost optimization, and security. You guys got it, right? Now let's come back to the architecture. Okay, so this is like a sample of, there are like, I'm going to introduce 5 patterns, but let's quickly take the pattern number 1. Pattern number 1 focuses on, let's take like a normal, some web application. When you are designing the web application, if you think whatever the 5 key pillars I told, it will be there. So we are choosing the compute, and also we are here in the one of the availability zone. So what is availability zone in AWS is, it's more kind of group of data center in a specific location. So in the data, what is the data center? That's where the applications will be hosted, where the compute, network, storage, security, infrastructure, virtualized, everything will be there. So availability zone is nothing but there could be multiple data centers. Okay, and in AWS, there is a concept called a region. Region is nothing but it's a group of availability zone. Maybe 1, 2, 3 availability zone. In one availability zone, how many data center will be there? Minimum of 2 to 4. Okay, that's the things. If you see here, we have an EC2 instance in one availability zone, and we have an EC2 instance and another availability zone also. On top of that, so that's where like our application is residing. On top of that, we have a load balancer. Okay, what it is like, this architecture, we are deploying the application, compute intensive application. If anything happens on AZ1, so when I say AZ1, it's availability zone 1. So we have a traffic distributed to AZ2 also. It could be like active passive or like a load sharing. Both of them is available. Let's see the pattern 2. So if you guys see in the pattern 1, it's more kind of single instance. Okay, one EC2 instance in availability zone and another EC2 instance in unavailability zone. It's more kind of like a monolithic applications. How many of you guys already working on microservices architecture? That's a de facto standard, right? It's becoming, so let's consider those kind of microservices, okay, compute like cloud native. If you see here, we have like a group of instance. What is the benefit of cloud native instance, right? As Hadley correctly mentioned, elasticity. We can easily reproduce, and within a nanoseconds, we can easily build it. Okay, so with that, we have a group of instances in one availability zone. If it gets fails, we can take it another things. So it keeps on doing that. So the third one is where the region comes into the picture. If you see the user is there, they have like a web application in one region and mobile application, kind of like a mobile app in another region. So what does that mean? If you take like a 3-tier architecture, web can be, we can use in one region, app can be, we can use in the another region also. It based on the design. But what is the key outcome here, right? You can distribute the traffic accordingly. most of the times like a global traffic. That's why like AWS has the CDN and Route 53. We can have the global network traffic. From there, we can route this kind of traffic to this web layer. Consider an example. If you're accessing Amazon.com USD, those kind of traffics located to like Singapore data center. If you're opening Amazon.com.in, it goes to India data center. Those kind of designs. Okay, and those entire database also. That's what I wanted to try. The customer database also located based on the region. This is more based on the application requirement. Okay, this is the fourth and final. I know like I'm going little fast because of running out of time. But what I wanted to make sure is the 5 key pillars you need to remember: operational excellency, performance efficiency, cost optimization, security, and reliability. And you know how it is. And whatever we are talking, it's more focused on reliability and scalability. Okay. So let's take a last one. This is like I explained about region, right? By saying that, what is the one thing comes to your mind related to application? Do you see like this application is active anytime? SLA Ryan mentioned, right? Here we are able to achieve the SLA because it's kind of like active. We have like a group of applications in code consider like a code banking in availability zone A. Same thing available for availability zone 2 also, and across the region also. What is the region? So Singapore is considered one of the region. Under one of the region, we have like multiple availability zone. Under one availability zone, we have multiple data centers. Same Singapore, we can have a Sydney. Sydney is another region, and we can have one more region in India, Bangalore or Hyderabad. That's another region, or like US. Okay, that's how we can scale the architecture. So, with the interest of time, I wanted to take a couple more minutes to answer that, to take out the questions.
Yeah, thanks a lot. We have about 3 minutes for questions, so maybe 2 questions.
And I'll be there. If you have more questions, I'll be roaming here. I'm happy to explain you. So now you guys, yeah, please go ahead.
You say one of the pillars could be security, right?
Yes.
One of the side patterns could cover the security, or
okay, whatever I talked about is more focused on scalability, but as part of the reliability, right? But not reliability. In security is analyze everything. For example, defense in depth. Whatever I'm doing, like for example here, it's more focused on the compute, right? You need to, whatever the data resides in the compute has to be encrypted. Data in transit, data in rest, data in transit has to be encrypted. Along with that, we need to include the zero trust model also. Who is accessing, what is the authorization, and what is the authentication, everything. So that's a key thing. Also, we need to do defense in depth towards the cloud, inside the cloud, and outside of the cloud. Okay. So this is more focused on reliability pillar. Any questions? And thank you for asking. Appreciate it. So you guys got it, like how do we scale step by step? You see like from one availability zone, one data center, one instance, and then compute instance, and cloud native, and multiple region. So that's how like we scale the things. And I think I'm running out of time. Next is lunch, right? Okay, we have one more speaker. Okay, perfect. So I'll be there. If you have any questions related to that, we can connect. You can ask me. In the meantime, this is my LinkedIn. You can connect, and we can explore. We can exchange the things. If you have any questions. One more minute, right? Okay. Maybe I can wait for one more minute until the speaker comes. I love to hear any questions, please. Okay. Resiliency. You already answered the question. Correct. Yeah, that's a very good question. Maybe let me summarize. So what is the need for multi-cloud in terms of resiliency? Because resiliency can be achieved with the single cloud provider with the help of multiple regions. That's correct, right? Okay. Multi-cloud push not only come from the application, it always comes from the organization. Why? Because there are 2 business benefits. One business benefit is consider I'm a customer. You are a cloud A and you are a cloud B. I can negotiate both of them, trade off. Okay, and some of times my developers will be there. He's skilled on cloud A, and he's cleared on cloud B. So I have the providing the democracy to the developer, to flexibility to the developers. These are the two things apart from resiliency. Okay, perfect. Sorry? When it comes to business, that's the first one, but it's strategically, that's where like important, right? Because some of the times, you know what, you take like one of the government organization in Malaysia, they may have, I want to store my data in specific cloud, where the data center is already in Malaysia. If you take cloud A, B, they are not there. Cloud D is there. If you take like Indonesia, Google is there, Google data center is there. So it depends on business, complaints, and also business application requirements. These are the three things. Along with that, in single way we are calling a resiliency by adding as part of the architecture. Okay. I hope like I answered all the questions. Please feel free to reach out to me anytime. Thank you so much. Yeah.
Yeah, that's me.
His talk is multi-cluster, multi-region, and multi-cloud deployment with Kubernetes. Dan is an instructor at Learn Kubernetes. And just a reminder that we are streaming today.
Okay. Okay. Let's see. So thank you very much for having me today. So my name is Dan, and today we're going to talk about a little bit about Kubernetes. I've got 20 minutes. The original talk was 40 to an hour with plenty of demos and stuff. So I had to cram everything into 20 minutes, which means, yeah, I have a demo. Hopefully it works, but it's a much shorter version than what I usually run. Okay, who am I? My name is Daniele, very hard to pronounce, so people call me Dan, Daniele, whatever, and people make fun of me because I do quite a lot of Kubernetes, so they shorten my name to D5E. That's me. I spoke at KubeCon twice. I'm a certified, oops, that's very quick. Not sure what's going on. I'm a certified Kubernetes administrator, so I spend quite a lot of time just researching and playing with Kubernetes. That's also part of my job. I work for a company called Learn Kubernetes. That's it. They basically teach Kubernetes, and that's why I spend a lot of time with it. And today, the talk of today is basically, we have these Kubernetes clusters. How do we connect them together if they are in different regions, in different cloud providers? Now, before we tackle this challenge, it's worth doing a very short recap of how Kubernetes works. So generally with Kubernetes, what we do as developers, or just someone interested in deploying, we have like a single unit and we say, hey, Kubernetes, please deploy some workloads for me. That's basically how it works. We don't really care what's happening under the hood. I mean, most of the time we don't. But in reality, what happens is Kubernetes will basically figure out where these deployments need to be placed inside your infrastructure. So we don't care, but Kubernetes does, because we still have to rely on servers, and we still have to rely on machines deploying these workloads. Okay, all good so far. What's next? So Kubernetes, the way decides how to place these workloads is decided by what we call the control plane. And the control plane is basically a collection of different controllers that work in tandem, that work together. And most of the time, there are 4 big blocks. I mean, there are way more than 4, but we are interested in 4 of them, which are the API server, which ingests your requests. And then we've got a database called etcd. Then we've got a controller manager, which is the brain of the operation. And then we've got the scheduler, which basically assigns workloads to nodes. That's basic. Right? So what happens when you deploy an application in Kubernetes? Well, that request, you say, I want to deploy something. That request goes inside the API server, goes through several steps of authorization, authentication, and just changing also the request on the fly. And then eventually it gets stored in the database in etcd. Once it's inside etcd, then it's picked up by what we call the controller manager. The controller manager is one of these systems that basically just syncs the state. So if you ask for something, it's going to check that you got what you asked for. In this case, it's asked for the deployment. The controller manager notices that there are 3 missing pods, and it's going to create them. Oops. Very, very quick. Not sure what's going on. So these pods are created. They are created in pending inside the database. They are written down to disk. And then, since they're pending, the scheduler is notified of the change, and it will pick them up and then try to allocate those workloads to particular nodes. Right? That's basically the end of the scheduling for these workloads. What's important to notice is that at this point in time, all you've done is basically just changing values inside the database. There is nothing actually going on inside your infrastructure. Right? So who creates this workload inside your servers? Well, we need something which is going to do the work, and that something is called the kubelet. So the kubelet is basically like an agent that lives inside your nodes, and basically what it does is just pulls down all sort of information about the node, right? And tries to reconcile the state of the node with the control plane. And if there is a workload, then it's going to create it, right? Or if there is a request to delete that workload, then it's also going to delete it. Whoa! I'm not sure what's going on. Not very trustworthy. Okay, so we got this cube. We got the kubelet. We know how the control plane works. Another thing that it's important to mention, is that the traffic does not flow through the control plane. So when you deploy these applications are serving web traffic, like production traffic, then this is not the kind of scenario we are looking at. Oh, I'm not sure what's going on, so I'm going to stick to resilience is on my clicker. Yeah, sure, that's a good idea. So what's going on is that the traffic doesn't flow like this. Instead of what we see is most of the time the traffic flows directly through the nodes. And these nodes are fronted by a load balancer. And then what basically means is that this control plane could go down and we can still serve traffic, right? Which is quite convenient for us, right? And now we know the basics. Let's have a look at how the basics apply when we scale this cluster from one single region, so one single cluster to multiple clusters, right? So the first idea is, okay, I've got an application, I've got an e-commerce website or a financial application that needs to be deployed into different regions for availability, for example. So the first idea you might have is, okay, I'm going to have a single control plane and then several nodes spread across regions. That's perfectly fine. There is, all the traffic will, of course, will be ingested by the nodes, which is great. But the reality is that some of the communication that you have between the control plane and the rest of the nodes will be slow, right? Because, of course, they're in different regions. You might say, okay, that's, I can bear the cost, I can bear the trade-offs. Let's do this. Then the same sort of problem you will sort of face when you deploy your applications, right? Because Kubernetes treats those nodes as equals, right? So you're going to deploy these microservices, and then they start talking to each other, right? So you might have cases where some of the traffic which is distributed inside the cluster is a little bit slower because Kubernetes essentially doesn't know that this traffic is going to be redirected somewhere else. Now, there are changes in the Kubernetes API to make it that a little bit better, but by default, this is what you get, which is, sometimes everything works fine, and then suddenly everything is super slow. Okay, so how do we fix this? Well, what if, right, we use one of these Kubernetes features to fix it? So instead of having a single control plane, right, Kubernetes can be designed, can be deployed to have multiple control planes. So the idea is, if I can have multiple control planes, and each control plane has got a database, and all these databases synchronize between each other, who is stopping me from deploying multiple control planes, and then eventually one for each region that I'm using in my infrastructure? No one is stopping me. I can do that. Does it solve the problem that we had before? Well, sort of yes, because these nodes, they can talk directly to the control plane in the same region, so that sort of communication should be solved. However, this introduces another issue, which is replication, right? So we talked about how this database needs to be replicated between instances, and the issue is that the database will write to disk only if there is quorum, right? So if the majority of the nodes agree on a value. In this particular case, it will take ages to agree on a value because they are in different regions and latency is very high. So this design is even worse than what we had before. So we know we can't really do a single cluster with multiple nodes in multiple regions. We know it's very tricky to do a single cluster with multiple control planes and multiple nodes in multiple regions. So what can we do? Well, the reality is that we can have a single cluster per region, and that's generally the better approach that you might take when designing this sort of stuff. However, when we do this, there are a few issues. The first issue is, how do we decide how to place these workloads, in which cluster we're going to place these workloads? This is issue number one. Second issue is, if I route the traffic to the US cluster or the EU cluster or the South Asia Pacific cluster and there is no app or it's overloaded, how do I route the traffic to the other clusters, right? And third one is, if I've got storage in one cluster and that application needs to move, do I need to move the storage on the other cluster as well? I don't know. So when I play with this sort of examples, then I found a quite interesting tool called Karmada. And basically the way it works is, it's an orchestrator of clusters. And you install a cluster, you install this software in one cluster, which becomes the manager, and then the rest of your cluster will become workers. And the way Karmada works is basically, we just send the request to the manager, and the manager will basically distribute these workloads across the entire fleet. And why is it good? It is quite good. I think it's quite clever in a way. It basically creates a mirror of your control plane, but this control plane is basically cluster aware. So it's aware that there are several other clusters that need to be orchestrated. And what happens is, you have an agent which is similar to the kubelet in a way, and then it's the agent which is basically going to send the commands to the individual cluster. So you have a single cluster which basically sends all of these commands to the agent, and the agent will send the commands to the cluster themselves. So that's basically how it works. But the interesting thing is, this Karmada, which is basically a glorified control plane for clusters, can have something called policies. So you can basically say, I want to create a deployment, and I want to go to just the US deployment, the US cluster. So if you do that and you submit the policy, we'll basically have a deployment just in the US. If I go back to my policy and I change it to the EU, so to Europe, then this pod will be moved to Europe, right? And there are also many other ways to describe how you want the state of the cluster to be. In this particular case, I say, I want to deploy 2 pods, and if I say duplicated, then Karmada will deploy 2 for each cluster I've got in my fleet. Or I could say something like divided, I could put different weights, or I can say aggregated, so filling one cluster first and then move on to the next one. And then there are more ways to configure however you want this to look like. This is so good. And when you deploy Karmada, the networking for Karmada is isolated to the cluster itself, which basically means that if the traffic is routed inside South Asia Pacific, so in Singapore, then it stays in Singapore. There is no way to share this traffic with the rest of the clusters. So what do? I want to be able to share this data. I want to be able to share this traffic with the rest of the fleet. I can do that if somehow I find a way to share this IP address and this information about workloads that have been deployed in my infrastructure. And the way we do this is basically by intercepting the traffic, proxying it to the other cluster, and then rewriting it when we are on the other side. And to do that, we use something called service meshes. So one way to solve it, it's not the only way, but one way to solve it is to use something like service meshes. So you might have heard this name, so Istio, which is what I use in the tool as well. So what are these service meshes and how they work? So essentially you have services, you have deployments inside your cluster, and then they all talk to each other. So when you install the service mesh, what happens is each of these applications will be fronted by a proxy. So all incoming and outgoing traffic will be filtered by the proxy. But this proxy is not just like a regular Nginx proxy. It's actually a programmable proxy that can be reconfigured on the fly. So the way it works is we've got another control plane, which is the Istio control plane, which on the fly will basically reconfigure the routes and the endpoints for these proxies, which gives us quite a lot of flexibility for saying, oh, I changed my mind. I don't want these two services to talk to each other anymore. Or I could say something like, hey, when you do the load balancing, can you please do a different split than 50-50 or round robin? Right? All this information is something we ask, we send to the control plane. The control plane will reconfigure these proxies on the fly. So that's how it works. What can we do with this? Well, if we can reconfigure on the fly, we could also say, hey, this traffic, we also have multiple pods in multiple clusters. So route this traffic somewhere else. And that somewhere else is basically the service mesh. So this is basically how the service mesh multi-cluster works. So we've got cluster 1 and cluster 2. And then when we install Istio, you can see the proxy there. The programmable proxy becomes part of your application. It's a single unit. And then when you install what we call the gateway, which is basically a way to connect these two clusters together, and then Istio will basically start sharing and discovering endpoints from the other clusters. Right? So this is basically where we share, this is my workload, this is yours, and we keep this information in the cluster. Now, when the traffic comes in and it goes to the proxy, then we have the ability to say, actually, you know what? I will send this through the gateway to the other side. And that's basically how we share the traffic. So what does it look like? So we've got a deployment. We know we can spread this pod across the cluster. We know we have policy. We can decide how to spread them in our fleet. And now we have this service mesh, which is also able to decide where the traffic should be placed. Now, we've done something basic. We just basically install the service mesh and connect to the cluster, but we can also do clever things such as always send the traffic to the local cluster, and if you're overloaded, go somewhere else. Right? So in this particular case, it's just a basic configuration. But at the end, we are basically able to ingest traffic in one cluster, and then if we want to, forward it to the others. Do you believe me? Someone say no. No. Anyone else? Okay, I've got 4 minutes to make it work. Let's see. Okay. Okay, so what I've got, hopefully it works. So what I have is a small script, and what it does is basically just send the request to the cluster and sees and basically check the response. Now, hopefully the Wi-Fi works. I have no clue what's going on or how slow it is. maybe we'll wait a little bit longer. Okay. So this is the dashboard I built. So I deployed 3 clusters today. Before I came, this is why I was late. I managed to just deploy the cluster. But what this dashboard is basically just pulling the data from the 3 cluster I've done, and then what happens is I've got here some radio buttons at the top where I can select where the traffic is going. So I make a request to the London cluster, or I make a request to the US cluster. And then I basically have a small application that replies with, let me see if the script works. No, of course not. That replies with a flag with the region where the cluster is deployed. So this, you can see here that when I send the traffic to the US, it takes ages, but most of the time it goes to the US and now it's going to London. Right? So I send the request to the cluster in the US, it travels all the way to London and then it comes back. Right? And if I switch to Singapore, then it goes to Singapore and then it goes back to London and then it comes back. So basically, this is Istio deciding that some of the endpoints that we've got inside our cluster needs to be routed elsewhere before they go back as a response. Here we go. Whoa! Okay, got it. So 2 minutes. Let me wrap up. So I think so. What we discussed today. So. We had a look at how Kubernetes works, so that was important. So we now understand how scheduling works in Kamada. So how do we manage to have policies that can spread workloads across clusters? We had a look at how different options that we have to deploy Kubernetes. So we could have a single control plane, multiple nodes in multiple regions, but we sort of discovered that the better way to do it, sort of easier way to do it, is to have a single cluster per region. We had a look at Kamada, so this tool. I mean, it's not the only tool that does this. So some of you might have used Argo CD to do deployments to the multiple clusters. Perfectly valid option. I was just interested in this one for my research. We sort of had a look at how Istio shares IP addresses between clusters and how this traffic is forwarded in the network using gateways. We also had a look at the demo, and it actually worked this time, which is excellent news. So I just want to thank you, everyone, for joining me today. This is me. I don't know how much time I've got. Maybe 30 seconds for questions. One is Linkerd, which is the second most popular service mesh. And then the third one is called Kuma, from the Kong guys. Yeah, I think, but yeah, those are the most popular, I guess, but there are many more options. So the question is, why do I need multiple control planes? So the reason why you need multiple control planes is because Kubernetes stores what we call endpoint. So endpoint is basically the IP address of the pod. And that IP address of the pod is used by several components in the cluster. So the components are core DNS, so the DNS system, the ingress. And what they do is they basically make an API request to the control plane and say, can I have back a list of nodes, please? With this list of IP addresses, please. With this list of IP addresses, they basically reconfigure on the fly the DNS, the ingress, and several other components to make the cluster work. So when you grab a control plane and you shut it down, if you don't do anything at all, your cluster will work. But as soon as you add the new workload, then first of all, I don't know how you're going to schedule that workload, but assuming that one of your workloads goes down, and that IP address is not available anymore, there is no way to update the control plane saying, hey, this IP address is gone. So your DNS, your ingress will still have a stale list of IP addresses and will still route traffic to those, even if you don't want to. Now, this is not great, but your cluster still works. So you don't have 100% downtime. You will have, depending on what's going on, you will have degraded service, but it's not like fully 100% downtime. So yes, we want to have multiple control planes because we want to make sure that these endpoints are propagated correctly. But again, it's trade-offs. it goes back to how etcd works and how replication in databases work. So the more a control plane you add, the slower it gets, and there are consequences to that. Okay.
This is the last talk before lunch. And so those of you who want to go to lunch, I would say go ahead. But if you're getting to stick around.
Yeah, okay, yeah, I am. Cool. I think Google Antus is a collection of tools. Kamada is just like open source tool focused on scheduling and multiple cluster. I think I'm not an expert in Antus by any way, but I think Antus is way more unified collection of tools that help you to deploy Kubernetes on-prem or in the cloud. So I think you can have Istio in Antus, that's for sure. I don't know how you would do multi-cluster. I'm pretty sure Google has got like a load balancer that can distribute traffic across multiple clusters. That's for sure. So I think they are quite different, as in different sort of aim for the project. Cool. Any other question? I guess the question is, where is lunch? It's basically just a collection of tools, like in the same way you would install Prometheus, or the same way you would install Istio. Then you install this in one cluster, and that cluster becomes the cluster manager, will basically become like this entity that can manage other clusters. And then it's a little bit weird because then your kubectl, then the same cluster will have two kubectls, right? Two kubeconfigs. One for the normal cluster. Then if you do kubectl get pods, you will see Karnada. And then there is the Karnada kubectl, same kubectl, different kubeconfig. And if you do kubectl get deployments, it shows you the deployment across clusters, which is like a control plane for the entire fleet you've got. And basically Karnada, what it does, it basically aggregates all of the kubeconfig from all of the other cluster, which is quite cool, right? You see a unified view of whatever is going on in your fleet. Yeah, it's on top. It's turtles all the way down. Oh yeah, all of the code for the demo is open source and it's online, so I can share the GitHub repo. Not an issue at all. Yeah, but this sort of stuff breaks quite easily, so I spent this morning fixing. As you can imagine, there are so many moving parts. I was like, okay, can I do it? No. Can I do it? Maybe. And then eventually I figured out how to fix it. Cool. I don't think that's the case, because the service mesh will basically do that work for you. So I think there are like several ways you can connect multiple clusters together. And then some of those will be like similar to what we do in AWS, like VPC peering, where you need to be careful about how you assign IP addresses. Like an example of that, I think, I never use it, but I think it's a product called Cilium Service Mesh. So this will be like a lower level. So we're talking about probably L2 for connecting clusters, right? And then Istio sits at the very top, right? Most of the time, layer 7. So in that particular case, we don't need any precaution when it comes to networking. But there are consequences on running a lot of proxies in your cluster when it comes to managing them, resources. It is not free. It is not free for sure. But it is an option if you've got these kind of problems. Cool. No one is asking where lunch is. Excellent. Cool. Thank you. Thank you very much.